Hello everybody, hola a todos, cześć wszystkim. In previous video, I showed you how to add transparent authentication and authorization proxy to existing cloud-native apps. In this video, I will show you how to add authentication and authorization from a JavaScript single-page application. Single-page applications are super popular, and their main advantage and beauty is that you can package such application and push it to the content delivery network and completely offload HTTPS traffic from your servers. The JavaScript application will authenticate to Keycloak using official Keycloak JavaScript adapter, and then it will talk to the backend services using REST API. So, if you watched my previous videos, you should have my repo already on your local machines, and you probably have Keycloak up and running up till this point. I recently added this whole section here, demo apps, and in this video I will show you how to deploy it. But first, let's take a look again at the demo apps architecture. Yes, you will be able to test it all from your local machine, as all the deployments are fully automated. Okay, so to date, we have only Keycloak acting as an identity and access management solution. It is deployed in Kubernetes and available at auth-localtest.me. We first will add our JavaScript single-page application. It is written in React and is deployed on GitHub pages at lukaszbudnik.github.io/hotelspa. You can use it, or you can fork my repo, deploy it yourself to GitHub pages or content delivery network of your choice. You could also, but not recommended, build the app and package it on a container and host it inside Kubernetes. But you will lose all the benefits of content delivery network. Your Kubernetes cluster will have to handle additional network traffic and additional computational resources to serve the static content. Also, all these applications are available. The links are available at the top of the README file, so you can check the repos there and you can fork them if you want. Okay, so we have this hotel spa single page application. The third component is the haproxy-auth-gateway. This is a transparent authentication and authorization gateway. We will pass the haproxy config with the configuration and the ACLs, and the haproxy will either pass through or block HTTP requests based on the JSON Web Token that we will get from Keycloak. It will use Realm roles for this. And finally, to illustrate the authorization part of the demo, I deployed 3 different services which requires 3 different roles to access them. Roles and service names match, so Camarero can be accessed by somebody with a Camarero role. Cocinera service can be accessed by somebody with Cocinera role, and finally Doncella can be accessed with somebody with Doncella role. The flow will look like this. The end user will open the single page application in the browser using JavaScript Keycloak adapter, authenticate to Keycloak, retrieve the JSON Web Token. Using the JSON Web Token, will pass it to our API gateway, API gateway will validate the JSON Web Token, and based on the realm roles, will either pass or block HTTP traffics coming to one of these three services. Okay, so yeah, let's build and deploy this demo now. First thing we need to do is to import a test hotel realm into our Keycloak cluster. I have prepared a ready-to-use realm and then exported it. So there's no configuration for you to do. Just import the complete realm definition and you will be all set. So let's take a look at what is included in this test hotel realm. Well, there will be two users, Julio with password Julio and role Camarero, Angela with password Angela and roles Camarero, Doncella, and Cocinera. There will be also a React client added. It will be of a public access type, as the single page application is hosted publicly. Mapper will be added. Realm roles will be mapped, will be added to JSON Web Tokens for this client. And I configured your application URLs to point to my GitHub pages location. If you will fork my repo and deploy to your own GitHub pages or deploy to your own content delivery network, this is something that you will have to change. How to import this? Copy and paste these commands. It just fetches the first Keycloak pod, copies the realm definition to this pod, and then starts a standalone Keycloak server with an action import, and it will import this file that we copied into the pod. I've already done so, and as you can see, it was successfully imported. So let's log in into Keycloak now. Let's log in into the administration console. And you don't see it. You don't see it because, as I just mentioned, we run it in a standalone mode. As you can see, we didn't connect to our existing cluster. So our cluster members don't know yet about this role. So what you could do is to scale replicas down and then up. When new pods will be starting, they will fetch the realms from a database. But we can actually do a quick workaround for this. We can quickly add a test realm, and Keycloak actually reloaded whole list of realms from a database, and we see the hotel here. So we will just delete this one and take a look at the hotel definition. First, let's check users. So yeah, as I mentioned, there is Julio and Angela. Let's check Angela, for example. And yes, she has Camarero, Cocinera, and Doncella roles. Let's check the clients. And we have React in here. As I mentioned, it is a public client. It has also mappers added here. Remember, yes, this is a built-in mapper, but it has to be explicitly added to the client, right? Otherwise, realm roles will not be added to the JSON Web Token. And in settings, as I mentioned, I provided the URLs to my GitHub pages. If you are to deploy your React client somewhere else, update these URLs. If not, you can use my GitHub pages. It will work out of the box. Okay, what's next? Okay, yes, we need our backend services. I'm using JSON project, which is a perfect tool for stubbing or mocking backend services in distributed systems, in distributed applications. It's perfect for our use case. JSON supports cores and returns JSON representation of basic information about the HTTP request and the underlying host. So we will be able to actually see the exchanged headers between our application and the backend. We will be able to see, for example, the JSON Web Token that was exchanged. We will be able to verify that the API gateway was working and routing the requests correctly. If you need more information about JSON, check out the repo, check out all its features, and yeah, hope you will like it and use it also for stubbing your own distributed applications. Anyway, I used JSON to mock three services, Donceia, Cocinera, and Camarero. Just execute this command and it will deploy those services in your Kubernetes cluster. The most important thing is that those services are headless services, so nobody can connect to them from the outside world. We need an API gateway in front of it. I've already deployed them, so I will move to the next point. And the next point is about deploying the API gateway. API gateway, apart of acting as a gateway to the headless services and routing HTTP requests to relevant backend services, will also act as an authentication and authorization proxy. haproxy-auth-gateway is a drop-in transparent authentication and authorization gateway for cloud native apps. It supports Keycloak out of the box. It will validate Keycloak signed JSON Web Tokens. It will also correctly parse realm roles from JSON Web Tokens. This project requires a public key of JSON Web Token issuer to verify the signature. You should never trust JSON Web Tokens, and you should always verify its signature. haproxy-auth-gateway project requires a public key to be configured. You cannot skip this very important step. For more information about haproxy-auth-gateway, check out the home repo. And yeah, let's quickly see its configuration. So we have those two files that I will be using. This one is the public key of the Keycloak hotel realm, and we have a haproxy config. These files will be created as config maps in Kubernetes and later mounted into pods and into containers. So let's take a look at the haproxy config. How does it look like? So we define some ACLs based on the path prefix. Later, we verify that HTTP requests that go to relevant backend service match the role. At the end, if all is okay, if JSON Web Token is verified, is valid, we route HTTP requests based on the path prefix to one of the corresponding correct backend services. So these steps are in here. As I mentioned, we first create those config maps with the issuer certificate and haproxy config file. We deploy the gateway, create TLS certificate for the API gateway, and then create the ingress. After this step is completed, we have the API gateway available at api.localtest.me. As I have here, it generates 403 forbidden because yes, I just opened it in the browser. I didn't pass any JSON Web Token to it, so it rejected my my request. And that's all of the configuration that we need. We can now use the application. Okay, maybe before we use the application, let's quickly get back to the README file. The last step is optional. You can use my application, which is already deployed to GitHub pages and is already configured in the Keycloak React client that we imported together with the realm. You can fork my repo and deploy it to your GitHub pages or your content delivery network, but then please remember to update React client definition in Keycloak and provide new URLs. Okay, so let's use the application. It is a React application. I'm using Keycloak JavaScript adapter. I'm using Keycloak JavaScript adapter in check SSO mode. This is a mode that does not redirect you to login page when you open the application. It only checks if you are already signed in into Keycloak. If yes, it will retrieve JSON Web Token and you will be able to use it. If you are not signed in into Keycloak, nothing will happen. This way, in check SSO mode, you can render, for example, the page for anonymous users or the users who did not yet sign in into Keycloak. So this is what we see, and let's sign in into the system. I'm being redirected to auth.localtest.me. The realm is hotel. I will change the user to Julio. Username and password is the same, and I will sign in. Okay, using the JavaScript Keycloak library, I know I parsed the JSON Web Token, and I know that Julio has only Camarero role. Normally, I would hide Cocinera and Donthea, but I show them always because I actually want to see the errors. So let's check Donthea service. Failed to fetch. Cocinera. Failed to fetch. Camarero. Yeah, that actually worked because I have this role. And let's check the output. As I mentioned, Yosoi will reply with a JSON message containing some basic information about the HTTP request and the underlying host. So for example, we can see the authorization header which our JavaScript application sent. This is the JSON Web Token that we retrieved from Keycloak. We see other HTTP headers in here, and we have information about the host name, and it is a Camarero pod. Okay, let's check Angela. Let's sign in as Angela. Password is the same as username. And Angela actually have three roles: Cocinera, Doncella, and Camarero. So let's check Doncella. And yeah, it succeeded, and we got a response from Doncella pod. Camarero, yeah, Camarero is working as well, and yeah, we got a response from Camarero pod. And Cocinera, yeah, we got successful response, and just to quickly verify it, yeah, it was returned by Cocinera pod. So yeah, that's all. Congratulations, you've just deployed a distributed application which uses Keycloak as an identity and access management solution. If you like the video, hit like button and subscribe to my channel. Thanks.